So what's the deal with map, filter, and reduce? Why do we use them so much in functional programming? And why do I call them the 3 basic functional tools? Hi, my name is Eric Normand, and these are my thoughts on functional programming. So map, filter, and reduce, most of us are familiar with them nowadays because they are now in JavaScript, just baked in, which is a good thing. I love that. But I have mentored people over the years, and I'm always surprised by how far people can get without them when they're using a functional language. And I'm surprised by, they get stuff done, but then I'm surprised that people that I think are at a really high level of functional programming have not adopted these things. So I just wanted to talk about, I think that they are a gateway. They're a milestone on the way to becoming a better functional programmer. So I wanted to talk about them a little bit more deeply than what they do and stuff like that. All right, so functional programmers use map, filter, and reduce. One reason we do that is we have a lot of data. We have a lot of sequences of data that we are passing around and manipulating. And so they do form a really nice way of doing pipelines, data transformation pipelines. You have data in one format coming into the pipeline through a series of steps. It gets transformed one step at a time until it gets to the last step. And then once it comes out the last step, it's the data you need, right? This is a standard functional programming pattern, data transformation pipelines. And each of those pipelines usually is a map, a filter, or a reduce. So map transforms one sequence into another sequence. Same number of elements, just each of the items from the first sequence has a function applied to it, and it becomes an item in the output sequence. Filter will keep or remove, depending on how you look at it, will keep or remove the items you want or don't want. Okay, it does both. It's keeping some and removing others. So you could filter for evens, and so all your numbers, you have all these numbers coming in, and then coming out, only even numbers are coming out. The odd ones are skipped. And then reduce is all about taking this sequence and reducing it down into some aggregate value. Okay, so if you wanted to find the sum is an aggregate, the sum of some numbers, you can reduce plus over them. Okay, you reduce the plus function over the sequence of numbers. And you start at 0, because that's the identity for plus. We learned that in algebra class. 0 is where you start counting stuff. And you reduce that down into an aggregate, which is the sum. You can do the same thing for the product. It's also an aggregate. You start with 1, you reduce a bunch of numbers using times, and then you have the aggregate, which is the product. You can reduce adding stuff to a collection, to a different collection. So you want to add stuff to a set. That's your aggregate, is the set, starts empty, and you just add one thing at a time until you got the whole thing. Okay, so we use these because they allow us to talk about the operations on the items instead of operations over the whole thing. So we're separating out the fact that it's working on a collection from how we're operating on the items, right? It's a simple thing. So let's just pipeline. So we can say, first, square all the numbers. So we map the square function over the numbers. And then we're going to filter for evens, so now we only want the evens, and then we're going to look up those numbers in a database. So we're getting new data back for each number as the ID, right? And then we're going to map the age attribute over all those things because they were people and they have ages, right? So now we have the list of ages, and then we're going to reduce and average them. Okay, so that's our aggregate, is the average, right? That's a typical pipeline, data transformation pipeline. Now notice you probably could have done all of that in a single for loop, right? You could have done each step as a single for loop as well. And that's really the origin of map, filter, and reduce. People noticed that, well, I could do this for loop where I have to manage an index variable and increment it and remember to exit the loop when I'm done, when I'm off the end of the list. You could do that. Or you could say, hey, there's this pattern I do all the time where I'm creating a new list that's like the old list, except each of the elements is modified. That's a map, right? I'm before my for loop, I'm like initializing this empty list, and then in the for loop, I'm adding a thing to the list each time, and then I'm returning it, right? Or I'm using it in the next step. And so what functional programmers have noticed is that there are only a handful of useful applications of for loops. I mean, let me put that another way. It's not that there's only a handful. It's that this handful comes up almost all the time, right? We're talking like 80-90% of the time. You still need a for loop for some weird cases, right? But it's not clear that you're not in one of those weird cases. When you're doing these for loops, you have this. There's a danger with for loops that you can do anything with them when there's only one thing you really want to do, and that's, say, map, or you want to filter. You want to eliminate some of the items from it. And so that's what's happened, is that over time people realize that it's safer, easier, clearer, more convenient to use these map, filter, and reduce than to use for loops. Now there's some conditions to using for loops. You need to have, or to using map, filter, and reduce. They are higher order functions, meaning they take functions as arguments, which means that you need first class functions. It's a prerequisite for having map, filter, and reduce in your language. And now, of course, JavaScript has always had first class functions, but Java has them now with lambdas. And so we're seeing a lot more people being introduced to these ideas of map, filter, and reduce. So in my perspective, they're just better for loops. They're better applications of for loops. You still need a for loop for those other weird cases, but in the cases where map, filter, and reduce are work, where they're used, then they're superior in almost every way. Now, I would say that one thing to increase your skill with functional programming, with the sort of tactical skills of functional programming, how to actually take this problem and code it up in a functional way. Learning map, filter, and reduce, try to apply it in new ways. I remember when I first started doing Clojure, maybe in my first year or two doing Clojure, I didn't use reduce so much. I was used to other languages. I did map and filter. Those I used quite a bit. But I started, because Clojure's immutable data structures really encourage it, I started using reduce a lot more. And I realized that there were a million places where it could be used that I didn't think of before. I would have used a for loop, or I would have written it recursively, maybe. Like I would do my own recursion. But for loops, it's so much better to use, it's so much better to use reduce than to do a for loop or recursion. It just works better. It's just better. You don't have to worry about, tail calls and all that stuff. It just works better. Now that's, you still need recursion. You still need a general purpose recursion. But when you can, use a reduce. And so that's my recommendation. Just go through your code and whenever you're operating on a collection, just think, is this a reduce that I'm doing? Map and filter are pretty clear. But reduce is the one that I think takes a little bit more pause and thought. Because once you make it into a reduce, it's so much easier, so much simpler. All right, my name is Eric Normand. Tell me I would love to hear your stories about applying map, filter, and reduce. Specifically reduce, because that one always gets interesting. Do you like using reduce? Do you prefer something else? Do you like nested reduces? Please say no. Please say no. All right, my name is Eric Normand. You can find me on Twitter at Eric Normand. Please follow me. You can also, and you'll learn about all these thoughts that I have had on functional programming. I share them all over the place on Twitter. You can ask me questions, tell me your opinions, get into a heated yet friendly debate over email at eric@lispcast.com. Please do. I love getting into discussions. And finally, I'm starting to get onto LinkedIn. So you can find me there. LinkedIn, I don't know what the URL is. Just search for Eric Normand, Clojure. You'll find me. I'm on there. Follow me. I'll try to follow you back. I share the same kinds of ideas, more business-centric. If you want your business to get into Clojure, if you think your company, the company you work for, needs to learn a little bit more about Clojure, hit like, hit thumbs up. Share it with your team. Awesome. See you later. Bye.